So let's review the ideas of phase changes. So remember, a phase is you can have three phases in general. You can have more, but for this class, we're just going to concentrate on three phases. We can have solids, liquids, and gases. Okay, so and let's say for instance that you were to remove an ice cube from the freezer, which was initially at minus 20 degrees Celsius, and then you're going to warm it by transferring heat. You put it on the stove at a constant rate. So what's going to happen? Well, it's going to start here over, and this is a plot of temperature versus time. So you have your ice cube at minus 20 here, and then as you warm it up, the energy of the ice cube is going to increase and the temperature is going to increase. The molecules are going to start changing. So then eventually it's going to reach a point where it's going to start becoming liquid. And at that point, the temperature doesn't change much for a bit. Then the temperature will increase. Now it's a liquid in this region until it reaches the point where it's going to start to boil. And for a little bit, the temperature is again not going to change until it keeps increasing. So let me show you a simulation that sort of illustrate this behavior a little better. And we have here, this is a solid and this is argon, right? We're going to change it to argon. This is a solid, and you can see the particles are stuck in one place and they are all tied together. And so now let's just make it a liquid, right? So the temperature has increased here. For the solid, we have 43 Kelvin. For the liquid, now we have 86 Kelvin, and this is the liquid. And you can see that now the particles move. Some of them just fly away, but they try to stay together. This is a compressible system. You can change the volume. An incompressible system, excuse me, you cannot change the volume much. And now finally in a gas you have 189 Kelvin here, and this is the gas state. So to describe these systems we use what we call a phase diagram. Here we have a phase diagram, right? This is a phase diagram for argon. And so a phase diagram tells you in a plot of temperature versus pressure what systems you're going to have. For instance, if your temperature and pressure are in this region, then you would have a solid. If your temperature and pressure are in this region, you would have a liquid. And if your pressure and temperature are in this region, you would have a gas. So right now, the temperature and pressure are right here, and I can add more particles, right? And as I add them, because they are it is a solid, they'll become part of the solid. So now let's just heat it up and see what happens. As we heat it up, then the temperature is increasing, 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 and now I am right here, and I have a liquid, and if I keep heating up, then eventually I'm going to have a gas. And so let me show you now for water the difference between one and the other. So let's just, this is water. And this is water in the solid state, and you can see these ring structures, and the water have this amazing structure when it is solid that allows the ice to be less tense than the actual liquid water. So let's change it to liquid now, and this is the liquid water, and you can see they are tied together, but they are not forming any structure as they, and this is the gas state. Right here, they are all flying together, flying away from each other. So let's look at the phase diagram of water. You can see, compare the phase diagram. This is argon, and you can see this line that is kind of inclined to your right. Now look at the water and compare that here. The fact that this line changes orientation has to do with the fact that ice is less dense than water. So let's just cool down and get some ice here. We're going to cool down. So now we are at 500 Kelvin. So this is 400 Kelvin, this is still gas. 300 kelvins. Now this is a liquid. Right there, this is a liquid. Okay, this is liquid water. And then we can continue going down, and now you can see ice, right? They form the structure here. So we are somewhere here in your phase diagram. Okay, so those are the phases. So we have three phases: liquid, solids, and gases. And we can switch from one to the other by heating up, by adding energy to the system. And the phase diagram allows you to locate, given temperature and pressure, where your system is going to be. For a pressure on this, say for a pressure of 218 atmosphere and a temperature around this, then your water would be a solid. If you were here, it would be a liquid, and if you were anywhere in this region, it would be a gas. So this is one of the reasons, if you are in high altitudes, then the boiling point is less than 100 degrees. So you need to cut your foot longer to because the water is boiling before you reach 100 degrees. Here's a quick question. If the pressure of liquid water is suddenly decreased, is it possible that the water will freeze, condense, boil, either A or B, and either A or C? Take a minute to answer this question and also look at the phase diagram of water when you answer this question. So now if we look at the phase diagram, we can see that you can have two behaviors. You can go from here to here, right? You decrease the pressure, right? So if you're liquid and you decrease the pressure, then you can basically become a gas. The water will become a gas. Um, Now, if you are here a liquid and then you decrease the pressure too, because of this behavior of water, which is unique, then you can go from liquid to a solid. So the answer is A or C. Okay, thank you.